In this video, I'm going to be discussing local area networks, or LANs. LANs are small networks of computers for your home or for your work office. It's important to understand these smaller networks because they are how the whole internet is built, is made up of these smaller networks. We're going to be focusing our attention on the lower level protocols that make everything tick. So as you are sending emails, as you're sharing files, as you're chatting with someone, you're browsing the web, you're watching videos, what's happening, what are the computers saying to each other, what's going through those cables. That's what we're going to be discussing on this video. It's just a general video to give you an idea as far as things that will be important for other usage later on that we're going to talk about. Now, higher level stuff, we're going to have some other videos coming out for the higher level protocols. For example, DNS, HTTP, email protocols, stuff like that. That we're going to be discussing later on. But your upper level protocols are up at the top on here, and that's the ones that the exact programs are using to talk to each other. You know, your browser, it's speaking HTTP, it's writing, it's interpreting the HTTP. Your web servers out there, they are. So your program specific type protocols are your high level ones. Down to your hardware is your lowest level. You know, what type of hardware are you running? How does it have to communicate? Is it dealing with a radio signal where the timing is built into it? Is it dealing with a parallel connection where you've got eight bytes and a timing? You know, you've got 8 wires for each one for an individual bit and a timing bit. You know, exactly how are they talking? That's really handled by the hardware level. So how this really is done, though, is that lower level's job is to facilitate communication for the MAC level, and the MAC level's job is to facilitate communication for the IP level as it goes all the way on up. That's the point behind how this works. We're going to give some examples on how this communication works on an example of a LAN, but for right now I'm just going to describe it. So we'll have that. So your program that you're working with, we're just going to use a web browser for the example. The web browser, you say you want to go visit a certain page. It needs to create an HTTP request. That is going to be sent. It's got to be packetized to be able to be sent. It's going to call the operating system and it's going to say, I want to open up a TCP connection to some other IP address. And that's where the operating system is going to say, okay, we're dealing with TCP. You've got a temporary port that you're sending it from, and you're going to this other TCP port elsewhere, as HTTP works on TCP. There's a bunch of other ones that are in that next layer there, but those handle your packetizing and they handle directing it to your program. That's part of TCP's job, and any of that layer's job is to hand it to the program that is going to be interpreting that. So it has that request that's been created. It's going to open that TCP port. The operating system's been directed to do that. And then in that TCP packet, it's then put inside of an internet provider or IP packet. And then that IP packet, for it to be sent out to the hardware, it needs to be put into a MAC packet or media access controller packet. And then it can be sent across your physical hardware as ones and zeros, as pulses of light, pulses of radio, pulses of electricity, whatever it's using to communicate between the computers. Then it can actually become that. It's those MAC packets that become those. And it may go across several hops where portions of those are read and they're stripped off and they're rewritten for it to be retransmitted across another hop. We'll look at those examples too. We're going to be looking at the bottom 3 particularly on the next set of examples. But then as we get to the distant end, that computer that we're trying to pull the web page from, it's got a web server on it. And it's going to receive that pulse of light or electricity or radio, whatever it be, in from its hardware, and it's going to receive that MAC packet that way. That MAC packet is going to be looked at and, okay, it's my address. This is to me. It's going to strip that off, that MAC packet, and it's going to pass it on to whatever's handling IP. Whoever's handling the IP system there, the operating system, is then going to look at that and it's going to go, okay, this IP address is my IP address. This is for me. I'm going to open the envelope now. And then it's going to pass it on up to the TCP side of things. That's then going to strip out that TCP packet, turning that into a stream to be read by the web server. And then the web server can then read that HTTP request, do whatever it does, which we're going to get into the details of that upper level in other videos. But then it's going to take that and it's going to strip off, it's going to turn that into a stream. And then that web server is going to receive that stream, and it's going to say, okay, here's a request for this document. Now it can form a response, and that response is then the whole thing's done over again. The TCP socket's created and it just goes back to the opposite way. So let's take a look at what this looks like on a map of a LAN too. So we've discussed one link and how that hardware versus MAC works together and how the IP works together as well. Now a router in here, the middle line here is a router, and that's going to be a gateway for an IP network. So it is a part of the network. Everything below it and it is a part of one network, and everything from it and forward is a different network. Now if you've got certain things that maybe have different types of hardware in there as a part of that link, like maybe you're running DSL on your router, so you're going to run Ethernet to the DSL modem. DSL modem puts it through the phone line, takes it over to the ISP, and then they're going to run it through a different modem that puts it into their system. It may have made 3 different hardware links, but we may have only had one MAC address in that process, where it's received by that ISP. The ISP has one MAC, and on the other side I have my MAC. Now, we've also got, most of these green ones, these are going to be just regular wired connections. The yellow over here is going to be a Wi-Fi connection. So we have a Wi-Fi enabled laptop. Now normally you're going to use whatever's most efficient on a laptop. You're not going to connect it with both systems. That just gets confusing for the laptop, and it also gets confusing for the rest of everything else, because the router doesn't know that that's one device connecting twice. So it's usually better off to say, which one do I need? Do I need portability, or do I need the performance of a cabled connection? And run one or the other. But for our example, we're connected both times. So a MAC address is given to each connection point. You know, we had the internet one. And for the most part, I don't think we really need to worry too much. Well, we will be worrying about the internet. And the internet could be also a wider area network. It's also referred to as the WAN side of your router. But it could also go to a larger network within your place. Maybe you have a office where every department has its own LAN, and then you have a WAN that runs everything else, a wide area network that covers all of the different LANs, and then that's connected to the internet. That's all very possible. The internet is usually just a whole bunch of routers, so once it contacts the ISP, they have a more complex setup of routers where they can contact various other routers and route that wherever it needs to go. Alright, MACs, though. We've got a MAC address for the router over there at your ISP or over there at your WAN, and a MAC address over on this side. The router is going to have it could have a MAC address for its connections on this side, where each of them might be calling the same MAC. And then we're going to have a MAC address over here on the security alarm system. Its connection is going to have one. Desktop's going to have one. Your laptop's going to have two of them. And the router is also going to have a separate MAC address for the Wi-Fi hotspot. So the laptop's got two of them, one for the cable connection and one over here. MAC addresses they're already set up. Your computer's going to know what MAC it's going to be. It's not going to get that from the network usually. Now, some routers know how to clone a MAC or just have it be hard set, but most of the time that's already in the network card, and it should be unique to that device. So a duplicate MAC address would make a lot of confusion on a network. So we've got everything here has those different MAC addresses, and an IP address is kind of an alias given to that within the network. So as I connect different things here, I can either have my IPs set up manually, where I tell my laptop directly, you will be this IP, and that only works as long as it is accepted by whatever's controlling that network, whatever's routing everything. So in this case, my router, if it doesn't say that I can have a certain IP address, and I try and take one here, whatever I'm expecting in the way of my traffic to that IP address, it isn't going to get to me. It's just not going to get routed. That's why it's always good to go ahead and set it up at your router and have your router do your IP configurations, and that's where dynamic host configuration protocol comes into play. It's also another thing too, for example, a laptop, real quick too. The laptop is something that would be portable. Perhaps you're using it at your home, then you take it to your workplace. If you already set that port to use a particular IP, then it's going to try and use that same IP whether you're home or at work. Now, DHCP can be used to assign the IPs as well as a bunch of other useful information dynamically. Because different environments are different, the router is for that environment. It works with that environment. Using DHCP, I can have each device get the appropriate and unique addressing that it should have. So if I'm using DHCP and I get over here on my laptop, I connect it to a new network. Maybe I've been using it at work all day. Now I'm coming home to finish up some stuff. I've disconnected it from my work. I come home, I plug it in. It's going to tell the Mac. It's going to call out its Mac, and it's going to say, I am this Mac, which is going to do a couple things. One thing here is any switch, which a router usually also has a switch in it as well, is going to have a MAC table, which means it knows where my MAC is. If I'm trying to get over here on my desktop and I'm trying to call over here to the security alarm system, I am going to be calling out I'm going to be calling out over here for the MAC that's over here, and then it's going to be calling the MAC that's over here, and it already knows where these MACs are. But for it to be able to call that router, the switch has a table in it that knows I've got one hop here, I've got another hop here, and being able to call all the way over here is where the IP comes in. It's a little bit better of a system for calling that IP, but I can look up these different MACs and I can say, okay, I want to call the router's MAC, and it knows, maybe I've got this connected to port 1 and this is connected to port to port 2 over here, and this is connected to port 3. It sees activity on port 2 that's trying to say it wants to contact the MAC of the router. It knows to send that out on port 1. It doesn't have to do anything over here with port 3. And the router is the same way. It's going to see that and, okay, I'm trying to contact, in that case it's using the IP tables as you're trying to contact over that far. And it's going to go ahead and look at that, and it's going to go, oh, that's over here. That's this MAC address, and that would be over here on port 2. I'm trying to contact out. That would be on my WAN port. Now for dynamic host configuration protocol, so it's going to announce its MAC, which means it's going to register that MAC on the switches table, and the switch is going to register it with the router. The router is also going to get a DHCP request, which is going to say, hey, I'm new to the network. Please give me my information to get on this network and make sense of it. Tell me what name you're going to be calling me by, because, yeah, that's the IP addresses. Which address are you going to call me by? And so it's going to contact whichever system I'm using, maybe both. It's going to have this over here. If it's calling out on here, perhaps we're using both. Remember? We said we were going to use both. So it's going to register it on this guy's MAC table for this connection, and for this connection it's going to be registered on both MAC tables, because it's going to be registered here and it's going to be registered here. Both of them are also going to send those DHCP requests that will send out a DHCP response, and both interfaces will be programmed, will be set by that. Now that can have a lot of very good useful information in it, such as a dynamically set IP address, which means I don't have to figure out what my IPs are. It's just going to make up one and use it, which is useful if I don't need to be running servers and all that on my network. I can also run a lot more than just a small number of computers if I'm cycling through these, if only the ones that are actively connected need an address. The ones that haven't been connected in a while, I can reuse those addresses. It's also going to send me information as far as where my DNS servers are, as far as where, if I'm trying to get a host name, where should I go? Because that could be different on different networks. It's going to tell me about my default gateway, my subnet masks, all of my information that I need to make sense of what I'm connected to. That way, all of what I used over there at work that may have been different, that went away. I disconnected. Now I'm back at home. Now I've connected to my home network, and my home router helps me out, gets all that set up. It already knows what I'm supposed to call for my default gateway whenever I'm trying to call outside my network. What do I need to do? My subnet mask, it tells me what is in my network, what is outside my network. When do I need to call my default gateway for things? And it can even set up all kinds of useful settings for you very quickly. So that's one thing that you can do if you did want to set up a dynamic. It's great for dynamic IPs, but it can also do static IPs as well. You can set up a static IP table on most routers that do the DHCP, on most DHCP servers, that will say, hey, recognize this MAC and always give it this IP address, and don't assign anything else that IP address. And that's something as well that can be done with DHCP. So you can still assign a static IP, but that static IP is only going to be for that network. So I'm not setting up on my adapter for my computer. I'm going to be setting this up on my router. That way, only when I'm connected to that router do I get that static IP. When I'm over there at work, I'm compliant with my work settings. So it can really set up a lot of those settings in there. Going through a router and making sure that you've got those things set up is can be the better way of doing things than just trying to go into your computer and manually set it there. But that's how these things talk to each other. You know, you've got those hardware links, and they find each other by the MACs and the IPs. Once again, so I mean, that's where we had, let's say if we had our IP that we were trying to route, this is going to have one IP. This is going to be distinct and different. This is going to be distinct and different to this, of course. This is what this thing sees. This is going to have one IP that's being used to talk on the internet. But then it's got one IP that it's got assigned to this, another IP assigned to your security system, one IP assigned to your desktop, another one assigned to your laptop's cable connection, and another one assigned to your laptop's Wi-Fi connection. So it's dealing with several IPs, but to be able to deal with that, remember that IP packet is going to be inside of a MAC packet as it runs along the hardware. So as I run it out to the switch, it gets put into, that IP packet is created, it's put inside that MAC, and it's put onto that hardware, and then it's received over here at that switch, and it's taken off that hardware and it's looked at. That MAC is for the router, so I'm going to pass it through onto the router, and then the router is going to take a look at that. It's going to pull it back off that hardware, so it went back on the hardware to get to the router, comes back off that hardware, it's looked at. Yes, that's my MAC. I pull it on out, I get the IP packet. Now that IP packet is actually addressed not to me but to the security system, so it's put back into a MAC packet that has the security alarm system's MAC address in there. That's how it makes that backwards hop, and it's put back on the hardware, goes on out, is received here. It's its known IP address. It opens up the mail. It pulls off the hardware. It's its MAC address, pulls it out of the mail. It's its IP address, opens that up. Then we're dealing with our TCP, UDP packets, opens those up, and hands those over to whatever application is supposed to be working on that. So that's how it's layered, and that's how it would work. And if I was also trying to contact outside, once again, I just have an IP that is set up to contact out here in the gateway and contact something else that's outside of that network. So those IPs, it's going to be read by the router. It's going to see that IP, and it's going to go, okay, I'm going to MAC this for going out over here and run it on the hardware to go out to the internet. That internet router is going to take that, strip open that, pull it off the hardware, strip open the MAC, take a look at the IP, and route it again. So it's just a constant process of that happening. That's how these networks work. So a lot of stuff is built on them, and we're going to have some other videos on what else is built on them coming up ahead. But for now, thank you for watching, and I'll see you on the next video.